Now, another common operation on vectors is multiplication by a scalar. Now, a scalar is just a fancy name for a number. So multiplication of a vector by a scalar is performed by separately multiplying each entry of the vector by the scalar, like this example. Now, to see that this definition is very natural, consider that you can view multiplication as a repeated addition. So if we are adding 3 times the vector 1, 2 to itself, what we obtain is the vector 3, 6, which is exactly the result of doing a scalar multiplication of 3 with the vector 1, 2. And now more generally, the multiplication of an n-dimensional vector by some scalar lambda obeys the following rule. And now to give you just a little bit of extra intuition of how vectors behave geometrically, at least in the 2-dimensional setting of real vectors, I will ask you the following question. So here you can see a vector in red. This is the vector 1, 0. Now you're allowed to scale this vector by multiplying it by any scalar of your choice. And you're allowed to also specify an angle that this vector forms with the horizontal axis. And now my question is, can you obtain any vector you want by adjusting these 2 parameters? You can pause the video to think about this if you'd like. So the answer is yes, you can obtain indeed any vector you want by adjusting these 2 parameters. So for example, if I wanted to obtain the vector 2, 2, I could multiply. So for example, if I wanted to obtain the vector 2, 2, I could multiply by the scalar, so more or less 3. I would have to roughly triple the length. And then I would have to choose an angle of approximately 45 degrees with the horizontal axis. So this gives me more or less the vector 2, 2. And you can convince yourself that you can obtain any other vector in this way.